Before you guys skip through the intro, just give me a quick second to explain what makes this build different than some of the other Voron builds that you've seen on YouTube. And so what I've done is I've taken this Voron Trident build, I've broken it down into different episodes. So right now you're watching episode 1, and this is going to cover the majority of the frame construction as well as the Y-axis motion setup. Now, in each of the episodes, what I've tried to do is I've tried to introduce a new part, a new feature, something new to the Voron build. And in this case, today we're going to be looking at some of these 3D printed parts. Now, traditionally, these Voron parts are FDM printed. What I've done is I've redesigned the parts to be multi-jet printed. And if you're not familiar with that technology, I'll put a link in the video description down below, taking you guys to some more information about the multi-jet printing. Bottom line is that it's far superior to the FDM printed parts, and I've redesigned the parts to be optimized for this printing process. And because the multi-jet technology is different than the FDM process that we're also familiar with, I was able to take its advantages and leverage off of them to create parts that are more accurate and more rigid, because previously there were two pieces that get bolted together, and now we can make parts that are a single printed piece. And of course, I'm gonna make these parts available to you guys as well on my website, embracemaking.com. So you'll be able to go there, and under the Voron Trident section, you'll find these parts available for sale. So check that out, embracemaking.com. And so I'm very excited to introduce these parts and incorporate them into a Voron build. I'm also going to be looking at the different Voron models and seeing how I can incorporate them, but I'm starting with the Voron Trident. And so why do I want to build a Voron in the first place? Well, I guess you could say that I feel the need for speed. So Top Gun just came out, so this reference is still kind of relevant. But anyways, what I really wanted to do was just see what this build is all about, and this machine and design intrigued me. And I thought that maybe, like I said, with these new parts, I could offer something new to the Voron community. So I hope you guys also appreciate what I've done here and would like to follow along with this build. So let's get started.
The Voron instructional PDF is pretty good, and I took their advice in starting this project by labeling all of the extrusions. As you can see, the instructions use letters to identify each of the extrusions, and you can use features like length, threaded holes, or through holes to tell them apart. The frame construction begins by using extrusions A, B, and C to build the rear left-hand bottom side corner of the cube. You're going to be using these M5 by 16 button head cap screws to create blind joints to fasten these extrusions together. On the C extrusion at the bottom rear of the machine, you want the access hole pointing upwards, and you can see it here, I'm pointing to it right now. You want that pointing up. Then you're going to take the B extrusion, and that's going to be the vertical member in this set, and you're going to look for the extra set of holes somewhere down the middle of the profile. Those are going to be facing forwards in the front of the machine, and the holes, as you can see, are not centered, they're offset in the extrusion, and so they're going to be biased towards the top of the machine, and again they're going to be facing forwards towards the front of the printer. I would highly recommend investing in some thread locker for this build, and you're going to see me using this stuff a lot. In this case, I'm using some blue Loctite. So this is a non-permanent thread locker. I'm going to be applying this to all of the bolts in the frame construction. This should prevent bolts from loosening off due to vibrations once we get the printer running at high speeds. Next, we're going to grab the H profile, and we're going to be using another M5 by 16 button head cap screw. We're going to be threading that into the bottom of the extrusion and leaving a gap because we are going to be sliding that into the rear C extrusion, the top T slot of the C extrusion, and we're going to be performing another blind joint. After that, we can grab 2 more A extrusions and 3 more B extrusions. The 2 A extrusions will be making up the bottom of the frame, and the 3 B extrusions will be making up the 3 remaining vertical members of the cube. Both of the A extrusions will get the M5 by 16 button head cap screws threaded into the ends of them, and these will be making up those blind joints with the vertical B extrusions that I just mentioned. Building a Voron is not an inexpensive endeavor, and it is very worthwhile investing in the proper tools. If you don't already have some sort of combination square, I would highly recommend getting yourself one for this build. In my case, with the 300 by 300 by 300 Voron build, I found that my 16-inch combination square fit nicely between all of the extrusions, and I was able to ensure that the whole frame was coming together very square. I cannot stress how important this is for the frame of your machine. It doesn't matter if it's a Voron or any other 3D printer that you're building. Having all of the frame members square is going to eliminate so many problems down the line, and it's going to ensure that you get the highest degree of accuracy with your prints. Now you can get 2 more A extrusions, and again, you're going to put those M5x16 button head cap screws into the 2 ends. These 2 extrusions are going to go on the left and right hand side of the frame, and eventually they are going to carry the linear rails for the Y axis. You will use the forward and rearward facing through holes in those vertical B extrusions to tighten down the M5x16 button head cap screws and form the blind joints for those members. You can use a combination square or carpenter square to ensure that these extrusions are square within the frame. However, what you can also do is remove the H extrusion that's sitting up there vertical at the rear center of the machine, and you can use that as a spacer and place that between the A extrusion that we're currently installing and the A extrusion at the bottom of the frame. And this is going to create the perfect spacing front and rear for this A extrusion that holds the Y linear rails in the future. In the Voron PDF manual, they mention using an extra extrusion to do this, but my extrusion kit did not come with an extra extrusion, and that H extrusion member is the perfect height to do this. I performed this step off camera, so you will not see me do it in this video, but I did take the extra minute to remove that H extrusion and perform this step to make sure that those 2 A extrusions will be at the absolute perfect height. Now we need 4 more A members to complete the top of our cube. Each of these members will get 2 button head cap screws M5x16 installed into the ends of each one, and again, these will be forming more blind joints with the vertical B extrusions. There are no special features or specific orientations to watch out for, so just get them installed as square as possible. During this process, there's a very high likelihood that you will have to go back and loosen off some screws in order to manipulate some of the members to get the frame squared up. Do not hesitate to do this. This is perfectly normal. Now we can get started on some of the belt drive system parts, and this is where I want to bring something unique to the Voron. I've taken the functional parts of this printer and I've completely redesigned them to be printed in the multi-jet fusion process in nylon 12 material. If you're not familiar with this process, I'll put a link in the video description down below where you can find more information. Multi-jet fusion uses a chemical binding process to produce the parts, and this results in parts with isotropic properties and that are far superior to regular FDM produced parts. If you're familiar with the Voron printed parts, what you'll notice here is that all of the parts that were previously 2 pieces are now a single printed piece. Therefore, in addition to the superior material properties, you'll now have parts that are inherently mechanically stronger because of their single piece construction. Another advantage are the tighter tolerances this process can achieve. This will ensure a higher degree of precision and a better fit and finish on your Voron. If you're looking for multi-jet printed parts for your Voron, be sure to check out my website, embracemaking.com, to order them. Now, similar to the regular Voron construction, we are still going to be using some of these brass threaded inserts, and you can use a heat set insert tool to press them into the multi-jet fusion parts, just like you would do in regular FDM parts. And so I'm going to be using my heat set press to install these threaded inserts into the tensioner pieces. And if you're looking to build your own heat set press, I've got you covered there too. I'll put a link in the top right hand corner of the screen right now to the video where I built this exact one. Melting the inserts into the multi-jet nylon 12 material is not very difficult. It is very similar to the regular FDM material where you do not want to go too high with the temperature and turn it into a soup. Once you've completed your parts, they should look something like this, and if you've had any extra material ooze out around the edges, you can just clean them up with a hobby knife. Now we can assemble one of our tensioning blocks, and I'm going to be using the right hand side as the example. And on the multi-jet parts, I was able to emboss the right and left side text on there, so it might be a little bit hard to see in the video, but it is clearly visible on the parts. It'll say right hand side, and these 2 parts will fit together. And so this is the front of the part facing the front of the machine, and the brass threaded insert will be facing the rear of the machine. We will be inserting the washing and bearing stack over top of this M5x40 socket head cap screw, and that's going to slide in through the top of this assembly. The bottom side can be identified by the cutout for the hex nut. Because the tensioner body is now manufactured as one piece instead of two, it is slightly more difficult to get the assembly together, but with a set of tweezers like this, you can do it. You'll notice that I first inserted the M5 shim, and I'm using these nylon shims. And as I do that, I am pushing the M5x40 socket head cap screw through the shim and now through the next bearing. And these are flange bearings, so the two flanges go on the outside to retain the belt. And once I get the second bearing in, there'll be another M5 nylon washer that goes above this stack to sandwich everything together. If you have small hands, it might be possible to do this without the aid of tweezers, but for me, I just found this to be so much easier, and it really only took me about a minute or so to get the whole bearing stack in there. And once you have all of the parts in place, then you can take your M5 nut and insert it into that hexagon recess at the bottom of the tensioning piece. And that recess is going to retain the nut such that all you have to do is tighten the M5 socket head cap screw at the top, and you won't have to hold on to the nut at the bottom. Do not over tighten this assembly, as the bearing needs to be able to spin freely. If you are over tightening it, you will find that the parts will start to bind, and the tensioning piece will also no longer be able to slide back and forth within the slotted hole. This would obviously defeat the purpose of this entire assembly, as the whole point of it is to be able to slide back and forth to produce the tension on the Core XY belts. One other thing worth mentioning here is that the Voron parts list shows regular M5 nuts, whereas in my video, I prefer to use the M5 locking nuts that have the nylon locking insert in the end to prevent them from rattling loose. The last piece of this puzzle is the M3x40 socket head cap screw along with the M3 washer, and that's going to go through the front of the part through the sliding belt tensioning piece, and the threads of this screw are going to thread into the brass insert that we just recently installed. Because there's no belt pulling on the bearing, it is normal for this piece to be flopping around even once you fully thread in the M3 screw, and so that will complete the assembly on this side, and we can repeat the process for the left hand side. The two assemblies will be mirror images of one another. Make sure your M5 bolts are tight enough that everything is not sloppy and there's no vertical movement, but loose enough that the bearings spin freely and that the tensioners slide back and forth. Now we can put together our bearing assembly for the A drive, and the A drive side can be identified as the piece with the brass insert. On the back, I've embossed the right hand side nomenclature in there, and I've just found this to be easier to identify the parts as left hand side and right hand side. Our first bearing stack will go together with two of the flanged bearings, and you can clearly see the two areas where the bearings go, and the smaller side is where we're just going to be putting in two bearings. The Voron PDF instructions call for two M5 shims on the outsides of these bearings, but because of the single piece construction of the multi-jet parts, the higher degree of accuracy, and no requirement for support material with these parts, I did not have to use those shims. Instead, I built them right into the part itself. Therefore, the two flange bearings will snap right into place, and then the M5x30 button head cap screw will thread itself into the plastic part, and the threads of the screw will self-tap into this material. Ensure that you do not over tighten this screw, as you do not want to bind any of the bearings. Once you find the sweet spot for the screw, just spin the bearings by hand and make sure that they turn freely, and there should be no vertical play in them whatsoever. After that, we can tackle our next bearing stack, and we're going to be stacking two sets of the flanged bearings. And in this case, we are going to be placing two of the M5 shims or nylon washers between those two stacks. Again, the PDF instruction manual will tell you that you need to put nylon washers on the outsides of these bearing stacks, but again, I have built these into the parts, so you will not need them. You just need the two that go between the two stacks of bearings. There is unobstructed access in the corner of this part, so you should be able to get this bearing stack in by hand, and you will be using another M5x30 button head cap screw to secure everything into place. And just like the previous screw, this one will self-tap into the plastic part, and you'll have to find that sweet spot where there's no vertical play in the bearing stack, but the bearings still spin freely. Once you're done, your part will look something like this, and then you can repeat the exact same process for the left-hand side, also known as the B Drive. Now we're going to be installing our stepper motors, and we're going to be starting with the A Drive, and so the A Drive again can be identified with the brass threaded insert. I'm using these steppers from LDO Motors, and we're going to be using 3 M3x30 socket head cap screws to install them, and we're also going to need the tooth pulley for the step and some Loctite. Insert the stepper motor through the bottom of the part, and the connector is going to be facing the outside of this part. Apply some thread locker to the ends of your M3 socket head cap screws and insert them through the part and tighten them down, and those will thread into the face of the stepper motor. The original Voron designed 3D printed parts use 3 holes. Now there is a space for a 4th socket head cap screw in my design, but it's kind of hit or miss. Sometimes it comes way too close to that bearing stack and it will rub on those bearings, so in my case I'm not going to be using it. Next we can install the tooth pulley, and that's going to go in through the top of the opening of the 3D printed part. Make sure that you apply thread locker to the grub screws in the tooth pulley so that they do not eventually come loose. Keep in mind that there is a flat side on the shaft of the stepper motor, and you're going to want to try to align one of the grub screws with the flat side of the shaft. This will also greatly decrease the chance of that pulley ever coming loose. If you need to rotate the shaft of your stepper motor, you can reach through one of the windows with some needle nose pliers and grab the stepper motor shaft and rotate it so that it aligns with one of the windows so that you can align the grub screw and then get your hex key in there to tighten it down. On the A Drive, you can see the orientation of the tooth pulley, and so the teeth are closest to the top of this part, and you're going to try and align the teeth with the top single stack of bearings. I was able to do this by eye just by looking through the windows in the part and using my hex key to manipulate the height of the tooth pulley, and then once I got it in the proper position, I could finally tighten down all of those grub screws. When I was finished, it looked like this, and you can see the alignment. Attaching the B Drive stepper motor is the exact same process with the 3 M3x30 socket head cap screws. Again, make sure that the connector is facing the outside of this part. And then we can attach our tooth pulley, and this is where things are going to be a little different from the A Drive side. Apply Loctite to the grub screws, rotate the stepper motor shaft so it's accessible from one of the windows, and then insert your tooth pulley upside down. So the teeth on the pulley are going to be closest to the bottom side of this part, which is where the stepper motor is located. Align one of the grub screws with the flat on the stepper motor and slightly tighten it down so that the pulley does no longer rotate, it just moves up and down. Now you will be aligning the teeth on this tooth pulley with the single stack of bearings on the bottom side. So this is that single stack of bearings closest to the stepper motor. Once you get it properly aligned, you can fully tighten down the grub screws, and your assembly should look like this, and you can see how the teeth in my part are aligned with that bottom stack of bearings. Now we're going to be mounting the tensioning assemblies to the frame, and to do that we're going to be using these M5 T-nuts as well as these M5x10 button head cap screws. You're going to want to install the M5 T-nuts in this orientation here such that the holes are biased towards the front of the frame. This is going to allow us to push the tensioning assembly right to the front of the frame so that it butts up against those vertical frame members. Don't forget that 2 of the T-nuts also go on the bottom side of this extrusion, and those will also be facing in the same direction as the top T-nuts. Now you can install the tensioning assembly onto this extrusion member, and these multi-jet printed parts are resilient enough that they will flex and snap into place on top of that extrusion member without cracking. So you can go ahead and do that, and then you're going to be using the M5x10 button head cap screws and those will be screwing themselves into the M5 T-nuts. And you're going to take that entire tensioning assembly, as I previously mentioned, you're going to push that towards the very front of the frame such that it butts up against the front vertical member. Don't forget to add Loctite, tighten the bolts top and bottom, and repeat for the right hand side of the printer. Make sure your tensioners still slide back and forth, and your assembly should look something like this. From here, we're going to be mounting the A and B drive assemblies. Now we're going to need more of these M5 roll-in T-nuts. I have 8 of them pictured here, but we're only going to be using 7 of them, and I'll show you why. We're also going to need more of those M5x10 button head cap screws. We can start by inserting the M5 roll-in T-nuts on this frame member here towards the back of the machine. And we're going to be using the same orientation of these T-nuts as we did with the front tensioning assemblies, so the holes should be biased towards the nearest vertical frame member. Right now we're looking at the right hand side of the machine, and this is where the A drive will get mounted. And so what you'll see here is that I'm only inserting one of the M5 T-nuts on the bottom of this frame member. Now we can take the A drive assembly, and much like the front tensioning system, these pieces will snap onto the frame, and then we can slide them towards the back, and we can use those M5x10 button head cap screws to secure this assembly into the T-nuts. Don't forget to add Loctite. The reason that the A drive only gets one of the button head cap screws on the bottom is that one of the holes in the 3D printed part is for a smaller screw. Later in the build, this smaller screw will be used for adding your choice of end stop. We can repeat the same process for the B drive side, except that on the B drive side, we're going to put 2 of the M5x10 button head cap screws on the bottom, because there will be 2 of the M5 roll-in T-nuts on the bottom of this extrusion member. Make sure you have your assemblies pushed all the way to the back of the machine, and it should look something like this. The D extrusion is next, and we're going to be inserting 10 of these M5 T-nuts. 4 of them will go on the top, and 6 of them will go on the bottom. Unfortunately, in this video clip, I will be inserting the M5 T-nuts on the outside of the extrusion in the wrong direction. What you want to do is you want to have the holes biased towards the outside. And so what you'll see here is that I have the outermost T-nuts installed backwards, and those need to be facing the other way so that the holes are closest to the outside edges of this extrusion member. I end up catching my error later on and fixing this off camera. Now we can take the extrusion loaded up with the T-nuts and insert it into the A and B drive assemblies. You're going to want to have the side of the extrusion with the 4 T-nuts facing up and the side of the extrusion with the 6 T-nuts facing down. The multi-jet printed parts will flex out of the way in order to get the extrusion member snapped into place, and once they're in place, you're going to use a tool to push the T-nuts to align with the holes in the 3D printed parts, and you're going to be using the M5x10 button head cap screws to secure everything down. As always, don't forget to add that Loctite. Now we're going to be installing these 3D printed gussets to connect this vertical member with the horizontal member we just installed. Now these parts here are regular FDM printed parts, and I did not multi-jet print them because I did not feel like it was worth the additional cost, and so they are just printed in regular PLA. Now this is not in the PDF manual, but I would highly recommend loosening off that blind joint at the bottom so the vertical member can rotate back and forth a little bit. This is going to allow you to better align these 2 extrusions that you are connecting with these 3D printed gussets, and then you can go back and retighten that blind joint. Install 2 more M5 T-nuts into the sides of the vertical member, and then you're going to be using more M5x10 button head cap screws with the thread locking compound to secure the gussets into place. Take note of the orientation of the gussets because they account for an offset in the 2 extrusion members. Your assembly will now look something like this, and then do not forget to go back and tighten down the blind joint on that bottom extrusion member, and also use your combination square to double check the squareness of your frame when you're complete. The y-axis linear rails are next, and you can see that I have the printer flipped upside down, so you're looking at the bottom of the extrusion that spans across the two vertical extrusions on the side of the machine. You may notice a few other parts that I have not yet addressed. Just ignore those for now because I had to do this printer assembly in a different order than the PDF manual. Long story short, I got sent the wrong parts and I had to delay this step in my actual assembly process. But for now, we're going to be taking these M3 T-nuts, and in my build, which is a 300 by 300 by 300 Voron Trident, I'm going to be using 10 of these M3 T-nuts on each of the linear rails. If you have a different size machine, then you're going to use a different number of these T-nuts, and essentially you're going to be putting a T-nut on every second hole in your linear rail. I'm arranging them such that the holes in the T-nuts are facing the outside of the printer, and so on the left hand side you'll see that I'm biasing all the holes to the left, and on the right hand side I will be biasing all the holes to the right. Place the linear rail on top and then start to align the T-nuts with the holes in the linear rail, and as I just mentioned, you're going to be trying to align them with every second hole in the linear rail. Now I had this issue where the end of my rail, that last hole, would not line up with these longer style roll-in T-nuts. The T-nuts that fasten the belt tensioning assembly as well as the drive assemblies are interfering with the T-nuts for the linear rails. This seemed odd to me because this was not something that was mentioned in the PDF instruction manual, and the multi-jet parts that I've designed are not any different in overall size. The hole locations and all that are the same as the original Voron parts, and so I don't know why I was experiencing this issue, but to resolve it, what I did was I took the T-nuts from the ends, so on the left hand side and the right hand side, and I replaced them with smaller style hammer T-nuts. Once you have that resolved, you can take your M3x8 socket head cap screws, apply your thread locking compound, and then begin to fasten down your linear rail. Do not fully tighten any of the screws until you have all of the screws in place, and that way if any of the T-nuts are still misaligned, you can get a Allen wrench or something in there to move them around and get the alignment right. Additionally, you can also download and print these linear rail alignment tools, and these are meant for 2020 extrusions, and so you can pop that on top of the linear rail and it will slide over the extrusion and ensure that your linear rails are centered on the top of your extrusion. If any of the screws are too tight at this point, the linear rail will not be able to shift around and you will not be able to get it centered on top of your extrusion. When tightening down all of the linear rails, I like to start in the center and work my way outwards. Despite the linear rails being seemingly very rigid, they still do have a certain amount of flexibility to them, as does pretty much everything. And so by tightening the screws from the center out, I like to think of it kind of like ironing out a shirt, and that is going to reduce the amount of, let's say, ripples or bumps that you induce in the linear rail if you were to tighten those screws at random positions all over the place. Also keep in mind that you're working with M3 screws here, so they're not all that big and you do not have to go crazy with the torque. Try and apply an even amount of torque to each of those fasteners, and at the end you can remove the alignment tools and run the carriage back and forth across the linear rail and make sure that you do not feel any binding of that carriage. If you feel like something is off or the carriage is binding or getting stuck, try loosening the screws and then retightening them again. You're going to repeat this whole process for the other side of the printer. Now we're going to be installing the Z Motion stepper motor mounts, and we're looking at the rear center of the printer, and so the printer is upright again. As you can see, I also redesigned these parts to be printed using the multi-jet fusion technology, and you can find these parts for sale on my website, embracemaking.com. To mount this piece, you're going to need 4 of these M5 roll-in T-nuts. 2 will go on the top face of this extrusion and 2 will go on the front face. And so that front face is facing the front of the printer. M5x10 button head cap screws will secure this piece into place, and as always, you'll be using some thread locker on these screws. Now we can install the rear center Z-axis linear rail, and very similar to the procedure that we performed on the Y-axis linear rails, you're going to be using these M3 roll-in T-nuts, and you're going to be inserting them into the vertical rear member at the rear of the machine. Half of the T-nuts will have their holes biased in one direction, and the other half of the T-nuts will have the holes biased in the other direction. Line up the T-nuts with every second hole in the linear rail and place the linear rail on top of your extrusion. More M3x8 socket head cap screws will be used to fix this linear rail to this extrusion. Again, do not forget the thread locker and do not tighten them down too tight at this point. We will be reusing the alignment tool for the MGN9 style linear rails so that we can align them perfectly on center with the extrusion. Also, before you fully tighten down those screws, push the linear rail towards the bottom of the machine, so that will be towards that Z-axis motor mount, and you're just going to want to leave a very small gap between the two parts. That small detail is covered in the PDF instruction manual, but I'm mentioning it here anyways, and now we can do our final torque from the center of the rail outwards. Finally, we can install the carriage stop for this linear rail, and I did not use the multi-jet process for these. These will just be regular FDM PLA parts. You'll need one M3x8 socket head cap screw as well as one M3 hammerhead T-nut along with the 3D printed end stop, and that will just get installed at the very end of the linear rail, and this is going to prevent the carriage from flying off the end of the linear rail and getting damaged. With the rear center complete, we can now move on to the front and the left-hand corners of the machine, where we are going to be putting the Z motor mounts on those two corners. By turning the printer frame around, we can get a better view of where these are going to be installed. The front motor mounts are also something that I redesigned and will be part of the Multi-Jet Fusion 3D printed parts packages. You'll need 4 of the M5 roll-in T-nuts for each corner, and these will get installed on the tops of the extrusions. The cornermost T-nuts will have their holes biased towards the corner of the machine, and the outside T-nuts, you can place the holes facing the center of the machine. Then you can use M5x10 button head cap screws to secure these parts to the frame. Don't forget the thread locker, and don't forget, as with many other parts in this build, you are tightening these screws down and clamping down on plastic parts. Do not over tighten them and crack your plastic parts. Once you're finished, repeat the process for the other side, and it should look something like this when you're done. The front 2 Z-axis linear rails are next, and to install these, the easiest way to do this is to flip the printer onto its front face. This process is absolutely identical to all of the previous linear rail installations we've already done, and so this is going to get skipped through very quickly, and we're going to get right to the point where we are installing more of the end stops for the Z-axis linear rails. Just remember to push your linear rail towards the bottom of the machine, so that's closest to the Z-axis motor mount, and leave a very small gap before you install this end stop. The end stop is installed with an M3x8 socket head cap screw along with an M3 hammerhead T-nut, and that is just going to be put at the very end of the rail, and very similar to the previous Z-axis linear rail installation, the purpose of this is to prevent the carriage from flying off the end of the rail. Make sure your Z carriage can slide back and forth freely without any restriction, and then you're going to repeat this process for the other side of the printer. Now we can take 3 more of the multi-jet printed parts that will eventually carry the print bed, and these are the parts that get attached to the Z-axis linear rail carriages. The front left and right hand sides can be identified with the embossed letters FR for front right and FL for front left. On the rear center piece, you will notice that the side of the part has 2 holes, and we are going to be using threaded brass inserts that we are going to heat set into these parts. Eventually, these 2 holes will interface with the cable chain, and the parts here with 2 holes are intended for use with the official IGUS cable chain. Some of the generic Chinese cable chains will have 3 holes in the last cable link to attach to this part here, but I figured since you are going all out with these multi-jet printed parts, you might as well get the high quality official IGUS cable chain for your build. And so using my heat set press, I'm able to melt those threaded brass inserts into the nylon parts. Now we can do a partial assembly of these bed support pieces, and we're going to need the lead screw nuts from our Z-axis lead screws. We're also going to need 6 M3x12 socket head cap screws, 6 M3 flat washers, and 6 M3 nylon locking nuts. Place the lead screw nut in through the bottom of these parts, and then you are going to be taking your M3 socket head cap screws along with a flat washer, and these are going to go in through the top of the part. The regular Voron PDF instruction manual does not indicate that you need flat washers here. I felt that it was a good addition because of the enlarged holes that will be used later on for alignment purposes. This gives the small M3 socket head cap screws more bearing surface area under the head of the screw. This will decrease the likelihood of those screws pulling through the plastic, and it will decrease the likelihood of them getting caught in the enlarged holes at a weird angle and then causing some sort of misalignment between your lead screw nut and your lead screw. Take note here that these pieces are now one piece compared to what you'll see in the instruction manual and what you've seen probably on other Voron builds where these parts are FDM printed. Do not fully tighten these nuts down just yet. We want things to be loose so that later on in the build we can get things properly aligned with our Z lead screws. Once you've done the left and right hand side, you're going to want to move on to the rear center piece, and this one is only slightly different where the lead screw nut comes in through the top and the screw will still come in through the top, but it is the washer this time that goes on the bottom with the nylon locking nut. When you're finished, you'll have 3 parts that look like this, and you can identify the front left and front right hand side with the embossed letters FL and FR on the 2 parts. We're going to be taking those 2 front bed support parts and now fixing them to the 2 front Z carriages. For each carriage, we're going to need 4 M3x12 socket head cap screws. And as we've done quite a few times in this build, we're going to add our thread locker and fully torque these screws down. After completing the left hand side, go ahead and also do the right hand side. The rear print bed support piece attaches to, you guessed it, the rear Z-axis carriage, and it also uses the M3x12 socket head cap screws. Now we can flip our frame upside down and start inserting the Z stepper motors with the lead screws into the Z stepper motor brackets. Make sure the connectors on the motors are facing the center of the machine, and that is in the front to back direction, not left to right. And as you see me doing here, you may have to manually thread the lead screws into the lead screw nuts on the parts that we just installed a minute ago. Once the motors are properly seated in the mounts, we're going to be using the M3x12 socket head cap screws to secure the motors to the mounts. Each motor gets 4 screws, and you're going to repeat this process for all 3 Z-axis motors. And the last components to be installed in this video are the printer feet. And on the bottom of the feet, you can see 3 holes, and you'll find the matching 3 holes on the trim pieces for the feet. And these trim pieces will be fastened to the main body of the feet using these M3x8 button head cap screws. Complete the process for all 4 feet, and then we can get them mounted to the frame. Mounting the feet to the frame will be done with more roll-in T-nuts, and we're going to be using the M5 T-nuts on the 2 side rails of the printer, and we're going to be using M3 T-nuts on the front and rear frame members of the printer. And so right now you can see that I have the printer tipped over on its side, and we're looking at it directly from the bottom of the machine. With the T-nuts in place, we can start installing the feet, and you're going to need the M3x8 socket head cap screws as well as the M5x10 button head cap screws. Apply thread locker to both types of fasteners, and it should be fairly obvious that the M3 socket head cap screws go into the M3 T-nuts and the M5 button head cap screws go into the M5 T-nuts. The sides of the plastic feet are different. One side is completely smooth and the other side has a sort of indent in it. You want the smooth side of the feet to be facing the sides of the printer, and you want the indented side of the feet to be facing the front and rear of the printer. Take note that on the bottom of the plastic foot, there's an access hole directly above the M5 button head cap screw, and this is intended for your hex wrench to pass through to access the button head cap screw so that you don't have to awkwardly tighten it from the side. Lastly, we're going to install the hockey puck style rubber foot dampers, and these are going to go directly on the bottom of the plastic feet. We're going to be using M5x16 button head cap screws as well as M5 nuts to secure the rubber dampers to the plastic feet. Repeat this on all four corners and you're done most of the frame assembly, at least for the Y and Z axis.
And so that's it for episode 1 of the Voron Trident build. Do not forget to check out my website, embracemaking.com, where you'll find all of these new parts available for your Voron Trident build. And in the next episode, we're going to be covering things like the X gantry assembly, the belt routing for the XY motion system, as well as the print bed installation. And in that episode, I'm going to be introducing more new parts, so keep an eye out for that. And as I mentioned in the intro video, I'm also going to be exploring doing all of these parts for the other Voron models, so not just the Trident. So if you guys haven't already subscribed, please subscribe to my channel and keep an eye out for future videos. Thanks for watching.